Welcome to the Tata Housing family. Please note, all workers and staff must use appropriate personal protective equipment while working on site. In this video, we are going to show you the best techniques for 2D precast and all the procedures we need to follow at every stage of precast works, starting from precast yard layout, setting up shed and required equipment, to production of precast elements and its erection procedure. There are many methods for production of precast elements. Here we are using advanced system, also known as carousel system. The following machinery and tools are an integral part of the carousel system. Selection of materials and inserts. We need the best quality construction materials needed for precast. Factory setup. First, we need to prepare factory layout to identify the location of batching plant, finished material storage yard and pallet movement area, rollers, plotter, curing chamber, concrete station, gantry crane, tilting station, QC laboratory for material testing and a plant office. Preparation for precast. Before starting work, supervisor or the engineer in charge must examine the production schedule, drawings. Cleaning and oiling station. Precast pallets must be cleaned thoroughly. A uniform layer of releasing oil is then applied all over the surface. Check for any damages and pallet level accurately. Plotting station. All the drawings are fed into the EBOS software, which controls the automatic movement of the pallet. In plotter station, the actual plot of the panel with the location of all the inserts is plotted on the pallet. Shuttering station. As per the panel dimension, side shutters are to be fixed using magnets. Foam releasing oil is applied on all side shutters and the magnets. Shear key, which is fitted on the mold face, needs to be placed first. The station in charge has to check the diagonal measurement and openings of the precast elements. Preparation of rebar cage for the element. It is important to ensure that reinforcement steel is tested and inspected before use. The number of bars of required shapes and length are mentioned for each element in respective drawings and bar bending schedule. Bars are bent and cut in a bar bending machine, where in the bending and cutting, details are entered as per the drawing requirements. Then a cage is formed by tying the bars as per the drawing and cover blocks are fixed to it. Panel members are tagged on each cage for identification. Reinforcement station. Respective rebar cage is shifted through EOT, electric overhead traveling crane, and placed. The station in charge has to check the correct cover for rebar. Accessory station. All the necessary inserts like dowel bars, module boxes, Electrical conduits, shear keys, etc., as per the shop drawing, are fixed in the pallet. Pre-pour inspection station. In the pre-pour inspections, following checks are required as per shop drawing: opening dimensions, positioning of inserts, positioning of reinforcement rebar, cleaning and cover for the rebar. The pallets are then shifted to the concreting station. Concreting station. Concrete produced in the batching plant is transported to casting yard. Check the docket for confirmation of grade of concrete, batching time, and then check for slump. Check the condition of pallet vibrator and sufficient manpower needed for concreting. Concrete must be poured slowly, ensuring that adequate compaction is done by use of a vibrating table. In this station, initial leveling of the concrete surface should be done. Finishing station. Post the initial setting time of concrete, start finishing the concrete surface using power floats with disc blades. This step helps in removing the minor irregularities and makes the concrete dense. Use a segmented blade for power troweling to achieve the required finish. Curing chamber. The stacker shifts the pallet from the finishing station to the designated curing compartment specifically meant for the pallet. Curing must be done for average 14 to 16 hours. Each pallet transfer is controlled by the master control software. Concrete cubes are tested at the laboratory for the desired strength. And only after achieving the desired strength, panels are taken out from the curing chamber and demolded. Tilting station. All the shear keys and thermocol inside the module box sockets must be removed before shifting the panels to storage yard. Next, the panels are shifted to storage yard. Demolded elements must be numbered and labeled for easy identification. Storage yard. Wall elements are stored vertically on A-type racks. Slabs are stored horizontally over wooden blocks and segregated depending upon type of elements. They are temporarily locked to prevent movement during lifting. Post-pores inspection must be carried out for each panel. Inspection includes dimension of the panel and location of inserts. Defect-free panels are approved by the site QC. In case the defects are beyond specified tolerance limits, panels are rejected. Transportation. Concrete cubes are tested at the laboratory, and only after achieving the desired strength, panels can be transported. The approved precast elements are transported to the respective position on the site for erection. Wall panels are to be transported on A-frame trailer and slab and beams on flatbed. The transported and approved precast elements are erected using suitable freestanding tower cranes of safe and sufficient capacity. While shifting, the elements are secured with safety belts. Wall panel erection. Coordinate points of the walls are identified on the floor using total station and marked with paint. Later, by using colored chalk and string, wall locations are marked on the floor. Before erecting the wall panels, shim plates are placed at multiple locations to facilitate proper level. Wall panels are erected as per these markings, and a sling is tied at the bottom of each panel for guiding the element. During lowering, the wall panel is brought near to the slab dowel bars to verify the alignment with dowel tubes. Care must be taken while inserting the dowel bars into the dowel tubes. After wall panel erection, wire loops are to be interconnected by a locker bar. The placed wall elements are propped temporarily and braced suitably for lateral stability and proper alignment. And adjusted by checking the verticality of the element with the help of a spirit level. After each wall panel erection, the following checks are conducted: room dimension, right angle at corner of wall-to-wall junction, verticality of wall using a spirit level. Before grouting, all the vertical joints need to be sealed with Baker rods to prevent any grout leakage. Horizontal joints between slabs and wall panels are sealed with mortar to prevent grout leakage. The panel-to-panel joints should be grouted with approved material. Grout mixing must be carried out at every floor as per the manufacturer's technical specifications using mechanical blenders. Pour the grout inside the dowel tube and the vertical joint using a funnel till it overflows, in order to ensure that the entire dowel tube and gaps are filled properly. Slab panel erection. Tripod props are erected to support wooden runners or doka. Check the top level of wooden runners using a level instrument. Before lowering the slab panels, all top stitch reinforcement bars of wall panels are slightly bent to avoid obstruction to placing of slab panels. Place the slab panels on top of the runners. After aligning the slab panel, check the top level. MEP and rebar connection work must be completed before starting the stitch concrete. Interlocking of reinforcement bars of slab and wall panels is done as per the design. Then all joints are cleaned by air blowers. Apply bonding agent for construction joints as per the manufacturer's technical specifications. Stitch concrete must be poured, compacted with needle vibrators, and finished properly. It is then cured for 7 days. Do's during precast production. Ensure proper concrete cover to the reinforcement. Ensure all the inserts are properly placed to prevent any dislocations. Ensure proper compaction of concrete and finishing as per specifications. Don'ts during precast production. Ensure that binding wires, rebars don't touch the shuttering. Ensure that no residual concrete is left on the side shutters. Do not add water at concrete pouring stations to increase the workability of concrete. Do not add excess water or cement on concrete surface to facilitate the surface finishing. Do's during precast erection. Only approved panels free from defects can be transported to the site. Elements should be demolded or shifted only after achieving the required strength. Check the room dimension, plumb and alignment of wall panels before joint grouting. Check the slab level and electrical connection before stitch concreting. Don'ts during precast erection. Excessive joggling of starter bars should be avoided. Do not remove the temporary supports before the stitch concreting achieves the required strength.